So the greatest common factor of monomials. First, we're talking about greatest common factor. We want to think about what numbers have in common. So for the do now, we want to list all the factors of these terms. So first we have 1 and 10, 2 and 5, and then nothing else goes into 10 perfectly. So I'm just going to expand the x's. So I know I have x times x times x times x. Those x to the fourth is the same thing as x times x times x times x. So I'm just going to expand that. And then for the next one, 35, I'm going to start with 1 and 35. And then 2 doesn't go in. No. But 5 does go in. So I have 5 and 7. And then I'm going to expand my x's. So thinking about what they have in common, what these two terms have in common, I'm thinking about, this isn't part of the question, this is it for the do now, but just getting ahead now into thinking about the greatest common factor. I'm thinking about how they both have 5s, and they both have at least 3 x's, right? They don't both have 4 x's, but they both have 3 x's. So the greatest common factor would be 5x to the third power because we have 3 x's. So that would be the greatest common factor of these two terms here. So a monomial are products of a constant and non-negative integers of x, like 3x squared. A polynomial is a sum of monomials, so poly means many. Poly means many. The greatest common factor of number is the greatest integer that is a factor of all the numbers involved. So for example, it would be this for these two terms. So we're going to try it for our model problem now. Step number 1 is to find the factors of each monomial. So for the first one, I have, looking at this, 25x to the 7th. So I have 125. And then I have 5 and 5 again. I don't need to write it twice though, but 5 times 5 is 25. And then nothing else goes into 25 nicely, so I'm just going to expand my x's. I have 7 x's. 1, 2, 3, 4, 5, 6, 7. For 10, I'll put this in a different color. For 10x cubed, I have 1 and 10, 2 and 5, and nothing else. Then I'm going to expand my x's. X times x is my x to the third. And then for my 30x to the fourth, I have 1 and 30. I have 2 and 15. And I have 3 and 10. And I have 5 and 6. And I think that's it. And then I have 4 x's. So 1, 2, 3, 4 is my x to the fourth. So now I'm looking at what they all have in common, right? I want to find what they all have in common. And what they all have in common, they all have 5s, but I'm looking to see if there's anything bigger, right? They all have 1s. 1s are going to be, that's too small. That's not, we're not counting the 1s. This one is a 25. Nothing else is the other ones don't have a 25. So I'm looking at the 5, and I think that is my greatest common factor here. It's the biggest number that they all have in common. The greatest common factor, the biggest number they all have in common. That's what that means. And then I know that I have 3 x's here, but I have more over here, but that's not, they don't have that in common. They only have 3 x's in common. See, at least 3 x's in common. Even though the other ones have more, this one only has 3, so we can only count 3. So our greatest common factor is our 5, and then x to the third, because we have x times x times x, which equals x to the third. And this is, right? This is x to the third, x to the third. So this is what they all have in common. This is our greatest common factor.